In this video, we're going to learn the naming rules for alkanes. There are naming rules for essentially all the different classes of organic compounds that exist. These naming rules and also drawing rules came into play or were determined or established by the IUPAC, International Union of Pure and Applied Chemistry, which is just a body of chemists and scientists that come up with these rules. Initially, the rules and naming and organic chemistry can seem a bit intimidating just because there's so much to know. But eventually everything's kind of the same. It's just a couple different patterns here and there that you notice and spot, and then it becomes pretty straightforward. You do have to put some work into it, but it's not that bad. Don't let people scare you away from it too much. So here I have the list of rules for naming alkanes and also cycloalkanes, the cyclic ones. I'm going to do a couple examples and go through the rules as I do the examples with you. So let's start off with naming this first alkane over here. So first of all, I have to recognize it's an alkane by realizing that there's no double bonds or triple bonds in it or no other functional groups. I also notice that it's a straight chain, so it's not a cyclic alkane of any sort. So your first step is to identify what's called a parent chain. So the parent chain is the longest continuous carbon chain there. And so there's a couple of ways that you can do this. You have to make sure you count your carbons carefully. So for example, this could be one possible chain. If you select that as your parent chain, that's 1, 2, 3, 4, 5 carbons. Some students might have said, hey, maybe this is my parent chain over here, this red one. So if they're choosing between the red one and the blue one, let's take a look at which one would win. It has to be the longest continuous carbon chain. So this is 1, 2, 3, and 4. The red one has 4 carbons, whereas the blue one had 5 carbons. So the blue one is indeed your parent chain. So your parent chain in this situation here is the one we highlighted over here as a blue one. And what you need to do is you need to name that parent chain. And since it's an alkane, the name is going to end in ane, A-N-E. If it was an alkene or alkyne, the name would end in ene for alkenes and ine for alkyne. So we're going to end in ane. Just to show you again, identifying the parent chain, this is another example over here. You could have chosen this as your parent chain or this as your parent chain. This one would have been wrong because there's only 5 carbons. If you went this way, this is correct because you have 1, 2, 3, 4, 5, 6 carbons. So this would have been your parent chain. So let's go ahead and name our parent chain. To name the parent chain, you need to, as I said, end it in ane, and also choose the prefix that indicates the number of carbons in your parent chain. There are 5 carbons in your parent chain. Okay, so 5 carbons in your parent chain. So there's a list of prefixes that you have to memorize. These are the parent name prefixes here. If you have 1 carbon, it's meth. Then there's eth, prop, bute, pent, hex, hept, oct, non, dec, and it keeps going. We usually go up to 10 in grade 12 chemistry. And then you just choose your ending based on what your parent chain was. So was it an alkane? If it was an alkane, put ane. If it was an alkene, put ene. If it was an alkyne, put ine. For now, though, we're focusing on the alkanes. So we have 5 carbons in our parent chain. So it's pent, and then we're going to put the ending ane. So our parent chain is a pentane parent chain. You'll notice that we're not quite done yet because the name really has to have a few parts. The name has the parent chain, so some part that identifies parent chain is an alkane, alkene, alkyne, the ane. How many carbons there are in there, the pent, so pentane, in the parent chain specifically. But also you have to have a way of identifying the branches. The branches are called substituents. There's different types of branches that can exist. You can have straight up just carbon branches. You can have branches of halogens. You can have different groups. If you have straight up carbon branches, the name for that is called an alkyl group. So for example, in this picture here, we have an alkyl group over here made up of 2 carbons. So it's a branch of 2 carbons. In our molecule we're naming, this is our alkyl group over here. We have a branch made up of 1 carbon. So we have to name this substituent. Substituents, you need to memorize how to name them. These are them over here. So a 1 carbon substituent is called a methyl. A 2 carbon branch is called an ethyl. And you'll notice it's very similar to the prefixes we learned before up here. It's just that we have the ending "il" because it's alkyl group. So that's how you know it's a branch, not a main chain. The "il" as opposed to the "ane", "ene", or "eine". 3 is propyl. 3 connected in this way is called isopropyl. We'll see that in more detail. 4 is butyl. Then 4 connected in this way here is isobutyl. There's secbutyl, terbutyl, pentyl for 5, isopentyl, hexyl, isohexyl, so on and so forth. And so if there's more, like if there's 7, that would be heptyl, 8, octyl, 9, nonyl, 10, decyl. So there's all those different, you just take the same prefixes from here and just put the YL for the name of your alkyl group. And that's essentially it. So we have a 1 carbon substituent here, alkyl group, so that's a methyl. So we're almost done. We also have to show where that methyl is located on the parent chain, because keep in mind that methyl could have been over here. It could have been over here. So we have to take a look at what the location is. And so what we do is we want to number our parent chain to try to get the lowest possible number for your substituent. What do I mean by that? Well, let's take a look at this example over here. Here we have 2 molecules. They're the same molecules, just the numbering is done differently. So this is the parent chain over here. And this is a substituent. So parent chain and substituent. And so there's 2 ways you can start numbering. You have to number from an end. You can't number from the middle of a molecule. You can't number from like here, for example. You got to start from either here or here. So suppose I start from the right side. I do 1, carbon number 2, carbon number 3. You count carbons. Carbon number 4, number 5, number 6, number 7, number 8. That means that my methyl group is on carbon number 6 here. So it's on carbon number 6. But if I start counting from the left side, 1, 2, 3, 4, 5, 6, 7, 8, then my methyl is on carbon number 3. And that's a lower number. That rule is called the first point of difference. I'll go over it in more detail soon because it's really important, especially if we have more than 1 substituent. Right now, we just have 1 substituent, so we want to get the lowest number possible, and that happens to be 3. So counting from the left is the best option. Now, in our situation, you'll notice it doesn't really matter which way you start counting from because this is right in the middle, so you'll always get the same number. It doesn't really matter where. So I can say this is carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5. So our methyl is located on the 3rd carbon. 3rd carbon. So now what we have to do is we have to put all these parts together. So we would write the position of the substituent. We would put a little dash here. We would then write the name of the substituent, methyl. And then no space, no dash, nothing. You put the name of the parent chain, pentane. This is 3-methyl-pentane. It has 5 carbons in the parent chain and 1 in the substituent, total of 6 carbons. Its molecular formula is C6H14, which makes sense because it's an alkane. And you're thinking, why 6? I thought it was 5. Well, no, there's 5 in the parent chain and 1 in the substituent. That's 6 total. Be careful with that. Students make a lot of mistakes there, which is why I kind of went over that exercise there just a minute ago. So that's really a simple naming example. Identify you have an alkane, find the parent chain and name it, find the substituents, name that, and tell me the position of the substituent. This is simple because we only had 1 substituent. Let's take a look at a situation where we have more than 1 substituent. And we'll take a look at an example where we have a bond line diagram drawn. So we'll try to name this one over here. So let's do the same exercise. Try to pause the video and try to find the parent chain, the longest continuous carbon yourself. If I were you, I would try to highlight a few different possibilities and then choose the one that's the best one. So this is one possibility here. That would be 1, 2, 3, 4, 5, 6 carbons. Another possibility that we could have had is Same direction sort of, but this time go up here. That'd be 1, 2, 3, 4, 5 carbons. Probably not that. I don't think so, because that's already smaller than a 6 carbon. Another possibility would have been same route, except go this way. And that would have also been 6 carbons. You'll see it doesn't really matter because they're both the green and the blue are both the same thing technically, just one points up, one points down. And another possibility could have been maybe this, like this. And that would have been 1, 2, 3, 4, 5, and 6 carbons. So that could have worked too. There's a lot of choice here. And in reality, any 6 carbon one that you chose would have given you the same name in this situation here. So as long as you chose a 6 carbon one, that is the best approach. And typically I like to keep it simple, so just choose the simplest 6 carbon one that you can for now. So we have a 6 carbon parent chain, and we know that that 6 carbon parent chain is going to be called a hex. Since there's only single bonds, it's a hexane molecule. Okay, but we do have substituents. So we have a substituent over here and over here. So this is sort of our main chain, and off the main chain, we connect up here. This is first carbon, and this is a second carbon. This is a 2-carbon substituent. And since it's an alkyl substituent, 2 carbons, it will be called ethyl. And this over here is called methyl. And so our goal in this situation here is now to try to identify where these substituents are located. And you want to start numbering such that you can get the lowest possible numbers for your substituent at the first point of difference. So let's do a different scenarios, and we'll see which is the best numbering scenario to choose. So I'm going to start numbering from the left side. 1, 2, 3, 4, 5, 6. If I number from the left side, my substituents are 3 and 5. All right, 3 and 5. Let me now number from the right side. 1, 2, 3, 4, 5, 6. If I number from the right side, my substituents are 2 and 4. So when you compare which one is the best one, you always look at where there's a first point of difference. Because sometimes you might have like the first, when you number from the left and the right, the first substituent you have, they both have the same number because they're at the same relative spot, sort of. But then the second spot, that's where the number is different. As soon as you see a difference in the numbers, go with the one that has the lowest number at that first point where there's a difference. So here, right away, right off the bat, 3 versus 2. 2 is a smaller number. So we're going to go with the red direction, going from the right side to the left side, because this 2 is smaller than 3, called the first point of difference. So we're going with the counting from right to left to have our substituents as 2 and 4. Now, so that makes it a 4 ethyl and a 2 methyl. Now, what order do you list these in? Well, when you list substituents, you have to list them in alphabetical order. Okay, so you have to list them in alphabetical order. So ethyl comes before methyl in the alphabet, E before M. So we're going to write 4-ethyl. Then we're going to put a dash. We'll put 2, or hyphen, I should say, hyphen methyl, and then hexane. No space between methyl and hexane there. And really you're just separating the substituents by those hyphens, 4 and 2. So now you've named it by telling me where the substituents are, what the substituents are, and also the parent chain is an alkane and its length. So 4-ethyl, 2-methyl, hexane. That's how you would name that molecule. We'll do the last example together here. and then we'll do some other examples below over here in the next video. So let's try this one here. We have a cyclic alkane. I know that because there's only single bonds. And so generally when you have a cyclic alkane, if it's the longest chain, continuous chain, then that's your parent chain. Okay. You cannot make a parent chain that's made up of straight chain and cyclic at the same time. If your parent chain is your cyclic one, then it's just your cyclic one, and the rest is substituents. You can have a substituent that is a cyclical molecule, but right now it looks like the longest chain, this is a chain of 2, this is a chain of 1. The longest chain happens to be that cyclic one. 1, 2, 3, 4, 5, 6. So normally you would call this a hexane, but because it's a cyclic version of it, you would call this a cyclohexane. So now you have to go identify your substituents. You have, so this is a substituent, 2 carbons here, ethyl, and then 1 and 1. So these are methyls. So let's take a look at how we could number this. You remember you want to number it to get the first point of difference. I'm going to do a couple different ways. So I'll start numbering here. I'll do 1, 2, 3. So that's one possibility, going that way. Okay. I can go 1, 2, 3. That's the same thing. So it doesn't really matter. Okay. Some of you might try this. Some of you might go 1, 2, 3, 4, 5, 6. So if you do that, you would have gotten 1, 2, 6. And the first point of difference is here. So red is still better. Okay. So the 1, 2, 3 way, red or blue way, doesn't really matter because it's 1, 2, 3. Now the trick here, though, is that we have 2 methyls this time. 2 methyls. And we only have 1 ethyl, so that doesn't change much. So for the ethyl, what we're going to do is we're going to name it as we normally would. It comes in alphabetical order, so 1 ethyl. Then you got to be careful. You have 2 methyls at 2 different locations. You have, sorry, it's not 1 ethyl, it's 2 ethyl. Let me erase this because it's a big mess here. And let me go back and just recount there. So we went 1, 2, 3. So 2 ethyl. Now the methyls, they're at location 1 and 3. So we're going to do our hyphen there, 1, 3. And now because we have 2 methyls, we have to indicate that with a Greek prefix. Remember the Greek prefixes from grade 11 and grade 10, mono, di, tri, tetra, so on and so forth. We have 2 methyls, so di. That doesn't count in our alphabetical order, okay? In terms of the substituents, like ethyl is still first. We're just going to put dimethyl cyclohexane. And that is our parent chain name, along with the substituents listed before. So the rule here is that if you have more than one of the same substituent, you have to put the Greek prefix in the front. If your branch was a cyclical molecule instead, so your cyclic part is not the longest part, you would put cyclo and then whatever length the carbon chain was. And this would count in the alphabetical order, but the Greek prefixes do not count in alphabetical order. They do not count in the alphabetical order. So that's essentially naming the rules for naming alkanes. We're going to do some more examples together in the next video here. I highly recommend you try these ones on your own first because there's a couple little complications that sometimes arise here, but otherwise not too bad. If ever you have a substituent that's not an alkyl group, so it's not just carbon hydrogen, but instead of halogens, you can simply use these as their names. So instead of for fluorine, it's a fluoro group, chloro group, bromo group, iodo group for halogens.